Hello, welcome to another tutorial of ProfLearn YouTube channel. In this particular video, we're going to have a discussion on how to solve differential equations, which involve separation of variables. And here we are told that the variables y and theta satisfy the differential equation 1 plus y into bracket 1 plus cos 2 theta dy d theta, and this is equal to e raised to power 3y. It's given that y equals to 0 when theta equals to 1 over 4 pi. Then we're supposed to solve the differential equation and find the exact values of tan theta when y equals to 1. And if you're new to ProfLearn YouTube channel, consider subscribing so that in time I'm going to upload further tutorials, you'll be notified. So let us just dive in so that we can be able to see what you really were supposed to do and what you are supposed to do when you are given such kind of equation. So I will start by writing how the differential equation was given, and the differential equation is actually given as 1 plus y. This part, so that I can rearrange that. Let me just rearrange it so that you can see exactly what I'm trying to say. So this becomes 1 plus y over e is to 3y, like that, and I believe you can be able to see. Then dy is equals to, I'm going to multiply this d theta on the other side and divide this 1 plus cos 2 theta, and then we're going to have 1 over 1 plus cos 2 theta d theta. So if you can be able to see this kind of arrangement I've done, I've arranged them such a way that those with theta are one side and those with y are on the other side. That's why we call this method of separation of variables. So we're going to apply various techniques of integration in order to work out this question. Now, I do some rearrangement here. For instance, this equation now I can be able to write it as 1. I can be able to write as 1 plus y into e to negative 3y dy is equals to, then I can see here I'm having double angle, and I need to remind you that when you are having cos 2 theta, this is the same as 2 cos square theta minus 1. So I can be able to replace this in the place of cos 2 theta. So this can be arranged as 1 plus 2 cos square theta minus 1. You can just write this one properly here. Then I have the theta at that given point. So that will mean I can be able to actually cancel this guy and this guy here, so that I'm going to remain with 1 plus y into e to negative 3y dy is equals to 1 over 2 cos square theta d theta. Something else that you need to remember also is that 1 over cos square theta is the same as sec square theta. And the reason as to why I'm doing this conversion is because we need to find the integral of this. We need to integrate this. We're going to integrate this part here. But according to your MF19, we don't have the integral of 1 over cos square theta direct. So I can be able to convert this to a part that you can be able to find its integration. So can say, therefore say this is 1y e is to negative 3y dy is equals to 1 over 2 sec squared theta d theta. So at this given point, we are going now to perform integration. We are going to integrate this part with respect to y, and we are going to integrate this part with respect to theta. Means that I can be able to try to integrate this, because if I look at this, I'll be able to, I'll integrate by parts. I'll integrate this by parts. But this one, we can be able to integrate it directly, because we're going to factor the half out, and then we integrate sec squared theta. We know the integral of sec squared theta is actually tan theta. So let's see. When you are integrating by parts, this is what you are going to do, right? You are going to use the acronym LIPET. LIPET. And remember, integration by parts is actually integral of two functions which are multiplied, because we have these two functions multiplied. So we are going to apply integration by parts. And that states that integral of u dv, right, is going to be equal to uv minus integral of v du. So this is the formula we're going to apply in the process of integrating these parts. So which means that we need to know what our u is, and also we need to know what our value of v is. So that's why I said we are going to use LIPET. LIPET means natural logs. This is an inverse trigonometric function. So LIPET enables you, LIPET enables you to pick wisely the value of u. So we are going to check in our part differential function, or in our integral, do we have natural log? If natural log appears there, you are going to take it as u. If it doesn't, you move next. Do we have inverse trigonometric functions? No, we don't. That if we don't, we move the next. The next one is polynomial. Do we have a polynomial? Yes, we do. This is now going to be our u, and the remaining part here is going to be our dv. Okay, so which means that in the process of working out this question, let me just subdivide this so that we can be able to work it step by step and see what we're going to get. So we're going to say u, and we have said u is actually 1 plus y. Then du is going to be, you are going to differentiate this. You are going to get actually 1, because if you differentiate this with respect to x, you are going to get y, 1. And then dv is going to be what? dv, we have said, is e negative 3. E negative 3y. Then v, we are going to integrate this, and upon integrating this part, we are going to get what? We are going to get, if you integrate this, you are going to get negative 1 over 3 is to negative 3y. Right. So once you have done that, we are going to multiply this part. In order to find the integral, you multiply across. So integral of 1 plus y e is to negative 3y dy is going to be, multiplying these two together, we are going to negative 1 over 3 e is to negative 3y, right, into 1 plus y, then minus. When you multiply this together, this one and this, you are going to get integral of negative 1 over 3 e is to negative y, e is to negative 3y, then y. So once we have this, you can see now the part that we have here is easy to integrate, because now we have this part being 1 over 3 is to negative 3y into 1 plus y. Then if we factor this out, we are going to have positive. This is a negative here. This is a negative here. If we take it out, we're going to have a positive. Then that is positive 1 over 3 integral of e is to negative 3 y dy. Then which means that this part we can be able to easily integrate it, and then we shall have negative 1 over 3 is to negative 3y into 1 plus y. Then integrating this, we're going to get plus 1 over 3, again multiply to negative 1 over 3, a is to minus 3y. Then, of course, we are going to introduce a constant, but we are going to do it later. So, okay, we can just introduce that constant there. Then we're going to proceed to the next part. So we already now have this integral at this particular point. We need now to work out this integration. This one is quite straightforward because we're going to factor out a half, and then if you integrate sec square theta is actually equivalent to tan theta. So we can therefore say this part is going to be a half, of tan theta is equals to, now I write this particular part for this part here, and that's going to be minus 1 over 3 is to negative 3y into 1 plus y. Then if we multiply this is going to be minus 1 over 9, a is to negative 3y, then plus c. Now this is the actual integral. Now once you've integrated everything, this is exactly what you are going to get for this differential equation. So, but we are not happy with this half that is here. We can be able to multiply through, and then we're going to remain with tan theta is equals to 2 over 3 negative e is to negative 3y, right? Into 1 plus y into minus 2 over 9 e is to negative 3y, then plus actually c. Okay, so once we have that, because if you multiply 2 by, remember c is a constant of integration. So if you are going to multiply by 2, again, you are going to get a constant. So that's now why I've actually maintained that c to be the way it is. Now, in order to find the exact value of c, or in order to find this constant of integration, what we're going to do is that we are going to substitute, because we are told it's given that y equals to 0 when theta is equals to 1 over 4 pi. So we can be able to substitute here. Where we have theta, we substitute 1 over 4 pi, and where we have y, we put 0 and see what we're going to have. This is actually tan 1 over 4 pi equals to, substituting 0 here, we are going to have 1 at this particular, because e of 0, raising e to 0 is actually 1. So this is going to be minus 2 over 3, because 0 plus 1 is 1. So we shall have 1 there also. And then minus 2 over 9, 1, then plus c. Then we, of course, if we can look at that, let us just try to find what the value of yeah, so we need to confirm what's the value of e is to 4. What's the value of e, just need to know where this is. Yeah, so we need to confirm what's the value of tan 1 over 4 pi. What's the value of tan 1 over 4 pi? Let's confirm that it's 1. Yeah, you can see now it's 1. Huh? So which will mean that this is equivalent to 1 equals to negative 2 over 3 minus 2 over 9 plus c. So which means that All right, so once that we have gotten this, we are going to now find the exact value of C, and you can now see our C is going to be 1 plus 2 over 3 plus 2 over 9, so that we can be able to know what is the exact value of this C that we are talking about. So if I say 1 plus 2 over 3, then plus 2 over 9, if I work it out, I'm getting my value as 17 over 9. So this is 17 over 9. This is 17 over 9. That is the value of C. But in this question, we were supposed to find the exact value of tan theta when y is 1. Exact value of tan theta when y is 1. What are we going to do in that kind of part? So with this exact value of C, we can say this equation actually, after working it out, is tan theta is equals to which one can I copy here? Let me just refer to this equation. Tan theta is equals to negative 2 over 3 e is to negative 3y into 1 plus y, right? Then minus 2 over 9 e is to negative 3y, then plus 17, let me write it properly, 17 over 9. Now, once we have this equation, we can now say we are finding the exact value of theta when y is equals to 1. So anywhere we have y in this equation, we are going to substitute 1 there. So this is going to be negative 2 over 3 is to negative 3, because negative 3 times 1 is that, and then we shall have 2 there, because 1 plus 1 is, remember, y is 1. We are trying to find the exact value of tan theta when y is 1, solving the differential equation. So as you are going to approach your exam, as you are going to do your P3 paper, know that you'll be doing question to do with the differential equations. And then you'll be told to solve the differential equation at a given boundary values. So this is going to be minus 2 over 9 e is to negative 3, then plus 17 over 9. So if you work out this, you are going to realize that your answer is going to simplify to the following. If you try to simplify this, you realize that your answer is going to reduce to what? It's going to reduce to, let me just find somewhere I can be able to write the final answer you're gonna get. You find that your tan theta, it's here. Yeah, can we fit here? Yes. So you can say tan theta is going to be equal to, this is going to be 17 over 9 minus 14 over 9 e is to negative 3. And this is going to, let's see, yeah. This is tan theta equals to 17 over 9 minus 14 over 9 e is to 3. So that is exactly what we can say that is the value of tan theta, exact value of tan theta.